Here we go. We're going to do a little conversion. This particular conversion is converting from grams to moles to molecules. As with every problem, we want to take a look at what's been given and where it is we want to go and let that guide us. So let's pull out in this problem 2.53 grams of N2O5, and we want to know how many molecules of N2O5 this is going to be. In our planning, we need to make a plan. When we take a look at where we are and what we want to get to, we're in mass and we want to get to numbers of things. That means we have to go through the heart. We've got to go to moles. In order to go from grams to moles, we need the molar mass of N2O5. So over here to the side, I'm going to write N2O5, and underneath it I will use how to calculate its molar mass. All problems involving molar mass that has to be calculated, you have to show the molar mass. You got to show me how you get it. So 5 times 16.00 grams per mole, and that is going to equal 108.02 grams per mole, and that's again N2O5. In order for us to get from moles to Avogadro's or to molecules, we have to use Avogadro's number. So I'm just going to write out 1 mole of N2O5 is equal to 6.02 times 10 to the 23rd. In this case, it's going to be molecules of N2O5. We are now ready to get this problem started. As with all of our problems, we always go back to what was given. So we're going to start with 2.53 grams of N2O5, and we're going to let the units tell us what goes where. So if I have grams of N2O5 upstairs, I want grams of N2O5 downstairs. So we're going to use the molar mass, 108.02 grams of N2O5, and right above it we'll go 1 mole, because that's what molar mass is, grams per mole. As a result of that, grams will cancel. We're now left in moles, so we're going to let moles guide us. So for every 1 mole of N2O5, we're going to use Avogadro's number now. There'd be 6.02 times 10 to the 23rd, in this case molecules, and unfortunately there's no abbreviation, of N2O5. And moles now cancels. I'm going to go ahead and pull out the numbers, but all we're doing is we're going to take 2.53 times 6.02 times 10 to the 23rd, all divided by 108.02. So let me just go ahead and pull that out just to make it clear what the actual calculation is. Times 6.02 is 10 to the 23rd molecules of N2O5, because that hasn't canceled, and that's all going to be divided by 108.02. So you're going to do it in your calculator, and when you do, your answer will be 1.41 times 10 to the 22nd molecules of N2O5. And again, we've asked you to box out your answers. So there you go. So for every 2.53 grams of N2O5, it would represent 1.41 times 10 to the 22nd molecules of N2O5. Okay, perfect. Yay. All right, we have a second problem. And I wanted to do this problem because it's very similar to the last problem. As a matter of fact, you'll notice we have 2.53 grams of N2O5, and it still is going to react in an experiment, although this time it's asking for how many atoms of just nitrogen are used. So we have to be very careful about the language. Up here, our language was molecules, and that means we wanted to know about how many molecules of this whole thing. But down here, we want to know how many atoms of just nitrogen are present in 2.53 grams. Now I'm going to show you two ways to do this problem, because maybe this problem is a standalone problem. So how would you do this problem if you were just given this? So here we go. The same thing is going to apply. We're going to hit 2.53 grams of N2O5. That's what we've been given. And we're looking for atoms of nitrogen. And again, this is a pretty important little step because it's going to help you keep your eye on the prize. Notice the difference between this and this. Down here, we're looking for atoms of just N, and up here, we were looking for molecules of N2O5. Since this problem is here, and we've already calculated the molar mass of N2O5, I'm going to take a liberty. We're not going to calculate that again. So let's get started. 2.53 grams of N2O5, and we can use the molar mass right away. For every 108.02 grams of N2O5, there would be 1 mole of N2O5. Great. So our grams is going to cancel. We're now in moles of N2O5. Now, what I'm going to do right now is I'm going to use the idea that 1 mole of N2O5 is composed of, or has in it, 2 moles of nitrogen. Where did I get that? Look at what it says here. 1 mole of this has 2 moles of nitrogen in it. I'm going to use that relationship. So here I'm going to say 1 mole of N2O5, and that's going to give me 2 moles of just nitrogen. Now, my moles of N2O5 cancels, and now I'm in moles of just N. So we're going to continue. Now we can use Avogadro's number. For every 1 mole of N, that would be 6.02 times 10 to the 23rd atoms of N. So that means we're going to take, I'm going to go ahead and do this. I'm going to push this up just a little bit. Okay, and work right here. So I'm going to say, all right, so what does that mean? That means we're going to take this. This says we're going to take our 2.53 times 2 times 6.02 times 10 to the 23rd, and this was atoms of nitrogen. And we're going to divide that by 108.02. And when we do that, our answer is going to be 2.82 times 10 to the 22nd atoms of nitrogen. We'll go ahead and box that out. Perfect. Yay. All right. Very good. Now, that's the long way. If this had not been a standalone, if it was like this, if this problem said how many molecules is this, and then you had a C portion that says how many atoms would this be? In that case, I'm just going to, let's see, I'm going to move this up just a little more. There we go. So another way, let me write this, another way. If this were a continuation, we're going to use the answer in number 1. What was the answer in number 1? The answer in number 1 is 1.41 times 10 to the 22nd molecules of N2O5. And we want to know how many atoms of just nitrogen this would be. Now, we can use this idea that 1 molecule of N2O5 is composed of 2 atoms of just nitrogen. If we do that, then we can say 1.41 times 10 to the 22nd molecules of N2O5, and we can say for every 1 molecule of N2O5 there would be 2 atoms of N. And what you would find is your answer 2.82 times 10 to the 22nd atoms of nitrogen. Your answer is the same. So if you were, again, in this situation, had number 1 been A and this second question was a B, you could have taken your answer from number 1 and just done a simple conversion. If it had been a standalone problem, then you could have gone from grams to moles, from moles of N2O5 to moles of N, all the way to atoms of N. Okay, it's time for you to practice. So I have a couple questions, and I would have you go ahead and copy them down. Go ahead and pause the video, copy them down, and go ahead and do them. And in just a minute, I'll show you the answers. All right, well, welcome back. Hopefully you paused the video. Let me pull this away, and I think I have to kind of go out just a little bit. There are your answers. Okay, well, good luck. If you have questions about how to convert from grams to moles to molecules, from formula units to moles to grams, I would encourage you to ask your teacher.
Dr. Lynn Quaid